Hello and welcome back to Steaming with Steve. Today we're going to go through how conditional statements look and how they can control the way that your program will go. So basically what happens is a conditional statement will be evaluated and then you will either go to the left or the right, depending on what has to happen. So let's jump on in and have a look. So to start, I've got a bit of a bad joke here. So if you're good and that equals true, you'll get ice cream, else you'll get broccoli. So the condition is being evaluated, are you good? And if that's true, then you're going to get some ice cream to see how it branches out. The other option, or otherwise, you're going to get some broccoli. So there's a branch that happens here. You're either going to get this or you're going to get this, but you can't get both. So that's what a conditional statement means. So some of the things that we're going to cover today, we're going to understand how to apply conditional statements in Python. So in particular, the if else, and the if else statement. We're then going to differentiate between double equals and the equals operator and their roles in conditional statements. Develop some skills in Python coding, including the correct indentation, which is how many lines across that your code will have, and then any of the logical flow control that you need to do. We're then going to conduct a desk check so you can see how to trace the code and understand what the flow of control means in conditional statements. So first of all, what's the most important symbol in Python? Well, it's actually a colon. So those two dots are the most important symbols that you'll see, and it's used regularly throughout your code. What it means is it's actually that a control structure is about to use or has been used, and that everything after the colon is important and it's attached to whatever the control structure that was used. I like to call it a snaky bite. So it looks like a little snake has bitten you, right? So from now on, whenever you hear me saying snaky bite, that means the colon, because it looks like a little snake bite. And that seems fitting while we're learning Python as well. So another bad joke, because I'm full of them. The problem about being a programmer, my mum said, honey, please go to the market and buy 1 bottle of milk. If they have eggs, bring 6. I came back with 6 bottles of milk. She said, why the hell did you buy 6 bottles of milk? I said, because they had eggs. Now, really bad joke, but you get to see the condition there was evaluated. So if that was true, the action was a bit ambiguous. So therefore, the person chose to bring milk instead of the eggs. Now, as a good programmer, we're very explicit. So we want to make sure that the person understands what we're asking them to do. So some logical conditions that we need to go through. These are all very important when you're evaluating pretty much anything that's got characters or numbers, and then checking to see if they're equal or not equal to. So double equals means that the thing is equal. So it's a Boolean operation. So it's checking to see if they're true, that they are comparable. If they're not equal, what we use is an exclamation mark equals. Now this is a little bit different to the assignment operator where we use a single equals. So if we want to check something, we need to use double equals. That's the really important part here. Then for the relational operators, you also have the less than, the greater than symbol. And then if you want to check less than or greater than or equal to, you basically have to put an equal sign at the end. So those are the 6 really important logical condition operators that you need to be aware of. And they always evaluate down to be either true or false. So the big question, what's the difference between double equals and just a single equals? Well, double equals is an equality operator. So it's looking to see if something's true or false. So it's comparing stuff. Whereas single equals is an assignment operator in Python. So what this means is double equals with the equality operator is checking to see the truth of the statement. So seeing whether or not it's true or false. Whereas the assignment operator literally assigns a value to a variable or an identifier. So usually it's assigning a number or a character into the background. So have a go at this, try the following conditions and see what you get as the output, true or false. So please just pause the video there and see what you get. Awesome, so let's have a go. I'm gonna open up idle. And we're gonna put in these values and see what happens. Go. A is equal to 1, B is equal to 4, C is equal to 4, and D is equal to 5. Awesome. So let's see what happens if we do A equal to B. You'll get false because 1 does not equal 4. A does not equal B. You'll get true because they're not equal. Does A equal C? Is false. Is A less than B? You get true. Is A greater than B? You get false. Is C less than D? You get true. And then is B less than or equal to C? You get true. Awesome. So hopefully you got those as well. So the flow of control, you may have heard me talking about that before. Basically what that is how does the program flow throughout all the different lines of text that you've put into it. So it's the order of statement of execution through a program, and it's generally sequential. So that means it follows one statement after another. The way that you swap this is with two things, which is conditional or repetition statements. So there are three main control structures that we need to understand. One is sequential, so the statements are executed in the order that they've been written. The next is selection structures, so that's where we decide whether or not to execute the code, which is what we're going to cover through today. And then the last one's repetition, so that means the statement is executed over and over inside of a loop. So these decisions are based on Boolean expressions, so either being true or false. And then this order of statement execution is what we call the flow of control. So I love the Big Bang Theory, so this is a little bit of a joke that's relevant for us. So let's have a look and see what happens.
How well do you know Sheldon's section? What did you put for his favorite amino acid?
Lysine.
Damn it, I had lysine and changed it.
Oh,
Basically,
good, you're
Sheldon's
just in
gonna
time.
work out how to
I
make
believe I've
friends.
isolated the algorithm for making friends.
Sheldon, there is no algorithm for making friends.
Hear him out. If he's really onto something, we could open a booth at Comic-Con, make a
And what you'll
fortune.
see here, there's a flowchart he's built.
See, my initial approach to Kripke had the same deficiencies as those that plagued Stu the cockatoo when he was new at the zoo.
Diamond. Trying to compare something.
To the cockatoo?
And that
Yes,
changes
he's new at the
flow.
zoo.
It's a terrific book. I've distilled its essence into a simple flowchart that will guide me through the process.
Have you thought about putting him in a crate while you're out of the apartment?
Hello, Kripke. Yeah, Sheldon Cooper here. It occurred to me that you hadn't returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yeah, perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time
False.
for a hot beverage. Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. Tell me an interest of yours. Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours.
Uh-oh, he's stuck in an infinite loop.
I can fix it.
It's interesting, but isn't ventriloquism by definition a solo activity? Yeah. Tell me another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on,
Then what you
Kripke.
should see, there's a loop counter that happens here.
A loop counter and an escape
controls
to the
the
least
exit.
objectionable activity. Howard, that's brilliant. I'm surprised you saw that.
Gee, why can't Sheldon make friends?
All right, Kripke, that last interest strikes me as the least objectionable, and I would like to propose that we do that together. Tomorrow. Yes, I'll pay. All right, goodbye. All right. Time to learn rock climbing.
So hopefully they picked up something from that where you can see how the different bits of code were really relevant to Sheldon in the journey there. So we go through what an if statement is. There's a whole different set of structures that you need to learn, and there's only really 3 of them that you need to understand. So in Python, there's an if statement where it comes down and evaluates something. So that, again, that diamond happens, and if it's false, you don't do anything. If it's true, however, you branch off and then do a certain statement. So there's no otherwise. The otherwise happens with an if-else statement. So if it's true or false, so if it's false, you go down here, but notice there's a new set of statements that you need to follow. Then if it's true, you follow these statements, but then see how they bypass these bottom statements. And then the last one I like to call the interrogation. So if this is true, go this way. If it's false, go this way. So if it's true, go here. If it's false, check this new statement, and then keep going until you get towards the end. So you can have multiple if statements that check these different values. So imagine something like a player control. If you want to press WASD, you might have different actions that happen depending what keys that you press. Then right at the end, you might have a default statement that basically gets executed if everything else is false, which is optional. So with an if statement, the else at the end actually is optional, which we'll go through a bit later. So an if statement, pretty simple. Like I said, it's like a post box, one of those old sort of mail where the little lever flag pops up. So if it's true, you would check the post box with the little flag up. If it's not up, then you would just keep moving on because there's no mail. So the way that I always visualize this particular statement, I call it the post box lever. And then if the condition is true, you do something. Otherwise, you just carry on as normal. So the way that this looks like in Python, it's really simple, is you basically have if, and then you check a condition. So you check a variable using those Boolean statements that we looked at before. And then if that's true, you execute everything that's indented underneath it. So if is a reserve word, it's one of those holy words of Python. The condition that we want to evaluate has to be either true or false. And then the snaky bite at the end, or the colon, means that a control structure is being used. Then notice that we've got the 4 spaces of indentation at the bottom here. So if the condition is true, these statements are executed. If the condition is false, the statements are skipped. So there's nothing that happens. So a quick little demonstration of how that looks. Let's open up the idle shell again, and I'll actually make a new script for this one. So here we go. So we're going to go x is equal to 2, y is equal to 4. If x is less than y, snaky bite. And then notice how to automatically indented it. Then we're going to print out x is less than y. Save that. And let's run it. And then because this is true, so 2 is less than 4, so this will evaluate to be true, then that bit of code there is executed, which is indented underneath it. Pretty cool, right? So your turn, have a chat, go at this. So create a program that prints out B is greater than A when we test 2 variables, where A is 33 and then B is 200. And then, yeah, so just pause the video and see how you go. Awesome. So what you should have had was this. So we'll build our own little script again. Here we go. So we'll go A is equal to 33. B is equal to 200. And if B is greater than A, snaky bite, print, quotation marks, B is greater than A. Save that. Pull that test to 2. And then run the module. Yep, there we go. So B is greater than A, which in this case 200 is greater than 33. Now just to prove that this doesn't work, if you make it the other way around and then we run it, what should happen? Nothing. Because this bit of code was not executed and therefore nothing was meant to happen afterwards. So indentation is really important in Python. So other programming languages use these curly brackets to control where things are. What Python does is it indents the text or moves it across inside of the line, and it has to be perfectly lined up with what is it's referencing. So indentation is the spaces at the beginning of the code line. That's really, really important. It's important in Python because without it, the programs won't run. So if you have this weird indentation with nothing lining up properly, with 3 spaces, then 5 spaces, and so on, it doesn't understand what's happening. So it's used whenever control structures are done. You need to have at least 1 space after if you use a control structure. By convention, most people use 3 or 4. I like using 4. I use spaces personally instead of tabs, just so that it's very clear that it's the same no matter what IDE that I'm using. And yeah, so basically that was the code that we just did before, which is legal. But if you did it like that, it's illegal. And the only reason that this one is illegal is because the last line of code was not indented. So you need to make sure that it's pushed across. Otherwise, the program won't run properly, which is really, really important. So then we've got the if-else statement, which is really cool. And the way this works is it pretty much branches down. So it checks to see if something's true. It goes that way, goes to the right. And then if it's false, it just goes straight down and executes that other code. Now, I call this one the fork in the road. So you're either going to go this way or you're going to go this way, and it branches off. So it's like a separation in the road. So I call this the fork in the road. So you're either going to go left or you're going to go right. And it's really important that you understand that the code doesn't get executed in the false statement, the false section, if the code was true, the condition was true. So really, really important that we know what's happening with this structure. The way it looks like in Python is really simple. Pretty much it's the same as what we had before, except underneath we now have this reserve word called else. So else basically is your backup. So if this is true, you're going to execute this. Otherwise, you're going to do this. And then it's really handy because it's basically like a net. So if something isn't true, you'll always have one or another way of executing the code. So if is exactly the same as before. The condition has been evaluated. And then the snaky bite is at the end of the if and the else. So that's very clear that it needs to be there. Else is a reserve word in Python. And then basically what happens is if the condition is true at the top, the statements underneath it are executed. If the condition is false, the other statements are executed underneath the else. Notice that the else doesn't need a condition because the else is totally attached to that first condition that you had at the top there. Okay, so like I said, it's either going to go this way or this way, depending on what happens. So really handy little demonstration. Here's what we did. So pretty much we're going to add on to the previous code, and what's going to happen is we're going to have an else option, which is not, which is going to split it. So let's jump into the idle, and we'll start up a new file, and then we're going to go through and go x is equal to 7. Then we're going to go y is equal to 5. And if x is less than y, snaky bite, print out x is less than y, else print y is less than x. So we're going to save that. Call that test of 3. And then we'll run it. Oh, have I done wrong? Oh, 7. Why is that beautiful? Let's go again. Here we go. So now we run that. What we should see, y is less than x, which it is. So see how y is less than x there? And then if I want to change this around, make 54, we'll save it, run it, and then see how it swaps it. So it basically allows a decision to happen with one or the other. Now this code has a huge flaw in it, which hopefully some of you picked up. If you've made both the variables equal to each other and you run it, it then will always say y is less than x because that is not true. So what happens with that is we'll eventually be able to fix that with the elif statements that we're about to do. So y is less than x. So your turn, have a go at trying to build this. Check to see if the two variables a is equal to 42, b is equal to 64 are bigger or smaller than each other. If b is bigger, print out b is greater than a, else print out a is greater than b. So just pause the video, have a go. Awesome, so let's have a go. So you should have done something like this. So if we go file, new file, put that off to the side. Here we go. So a is equal to 42, b is equal to 64. If b is greater than a, snaky byte, print out b is greater than a, else print out a is greater than b. So now if we save that and then run it, got this, which is pretty cool. So b is greater than a, which in this case it is. So 64 is greater than the 42. Fantastic. So the next one we have is the if, elif, else statement, which then helps if we have, like for example, before we had 3 different conditions we needed to check. So this is what I call the interrogation. So if this condition is true, you're going to branch off and execute this statement. If it's false, you're going to then come down here and check another condition. And then if it's true, you're going to branch off. If it's false, you're going to keep going down all the way down to the end. And then at the end, you've got the false statement down there. So like I said, I call this the interrogation. Is this true? Was this true? Was this one true? Blah, blah, blah. And the easiest way to think of it, I always think about it, is player controls on a game. So if you press the W key, what happens? If I press the A key, what happens? If I press the S key, what happens? If I press the D key, what happens? And then basically you'll have those conditions that check through. So this is like a little interrogation, and you keep testing the different conditions. As soon as the condition is true, you're going to do something. Otherwise, at the end, you've got that little statement at the end to wrap it all up, or you might just skip off and do nothing at all. So it's like a filter. It goes through and checks all these different conditions until it's true. This is the general structure. So the main difference that you'll see compared to what we've done before is the 2 lines in the middle. And what that means is it's basically another if statement that's been checked. So every time you need an if statement at the start and then an elif underneath each if statement to have another condition to evaluate. So if this is true, execute this code, elif, execute this code, and then else at the end. So if is a Python reserve word, and these are the conditions that get evaluated, and then the snaky byte at the end. So that's a control structure has been used. And then we have the elif reserve word. So that's the only thing that's a little bit different when we use the interrogation method. At the end, like I said, else is optional. So you don't actually need to write an else statement if you don't want anything to happen. So for example, with the player controls, if you don't press any key, you actually don't want anything to happen. So that's why it's optional at the end. So depending on the condition that's true, particular statements get executed. Otherwise, nothing happens. So a little demonstration of how that works. I've got a simple animal checker little game here. So we're going to go new file. And we're going to make a variable called x. And we're going to make that equal to a cat. Then we're going to check to see if we can find the cat. What happens if the animal is a cat. So if x is equal to a dog, snaky byte, print x is a dog. Elif, so not else, we now use elif, and then now we've got another condition we want to check. So x is equal to a pig, snaky byte, we print out x is a pig. Elif, x is equal to a cat. Oops. do a snaky bite, print X is a cat. And then at the end, else print X is an animal, which may be true. And then now we run it. So if we save this one, and we run it, X is a cat. So it was able to go through and compare this variable that we set at the top, X, against each of those things, and then at the end it saw that it was a cat. So if we change this up top, let's say we put it as a dog, this little variable checker system is going to go through and it's going to be able to see that it is a dog. If I then say, let's say it's a unicorn, and run that, it's going to say it isn't an animal, which is true in this system, but this is where we have to have a list of all the different animals that we want to compare against. So it's very, very important. So the next one I want you to have a go, try and do your own challenge here. So the following program, check to see if the statements, to see if the variable pizza, pasta, or a schnitty, or not known food. We're going to set the X to be equal to pasta. So it's very similar to what you wrote before, and see if you can build this from scratch. So try and not copy what I've done. Try and do this by yourself. So just pause the video. Awesome. So hopefully you had a good go at it and you were able to build something like this. So the way this looks like, if we go through it, up here, so I'm going to go X is equal to pasta, because that's what we're going to, the variable we're going to check off. Then we're going to go X is equal to pasta, pizza, sorry. Snaky bite. We're going to print out X is pizza, because that's what it was. Else if X is equal to pasta, notice that I've used the quotation marks. They're going to print out X is pasta. If X is equal to schnitty, print out X is schnitty. And then at the end, we've got else. We're then going to print out X isn't unknown food, because there's no one else that you would like to eat. So now, if I run that, and we run it, X is pasta. So it's able to go through and check. It found that the variable was equal to pasta, and therefore it had a match, and then it outputted what needed to happen. You can then change this around. So if we change this to pizza, save it, and then run it, you'll get X is pizza. Pretty cool. The last one that we have then is the match statement. So match statements are a little bit different. What they do is they allow you to do an interrogation on a single variable, and then you check the different patterns against each other. So what happens here is you're using snaky bites again, but you're checking the cases, and where case and match are the new reserve words that we're going to need to know. At the end, instead of else, we actually use a default value, which is what the underscore means, which I've sort of alluded before. And that's just to show that there's a significant variable at the end. So depending on the values of true and false, depends on what gets executed in this lines of code. So match demonstration, really simple. I'm going to copy what we've pretty much done before. We're going to check to see if the variable X, I'm going to have these different cases that we check against. So instead of using elif all the time, it's basically just going to go through and trying to find the right case. So let's open up the idle again. We'll go new file. And this is just another way of doing it. So this is a relatively new structure. Python hasn't always supported this. A lot of other programming languages have it. So we're going to go match X. So some other languages, they call it a switch statement. I'm going to go case it's a dog. And then we're going to print out X is a dog. We're then going to check the case if it's a pig. And then print out X is a pig. We're then going to check the case if it's a cat. and then print out X is a cat. Then we're going to have the default case at the end. So check that case and then print out X isn't an animal. Save it. And then we run it. And bam, X is a cat. So same thing again. Basically, we'll cycle through checking this variable that you've inputted and then checks against each of those different cases. Have a go at this one here. So this is a little test to see if you got it. Check to see the different basketball sporting variables. So basketball, volleyball, rugby, or not a known sport. Set the variable to sport and let it equal to basketball. So pause the video here and see if you can do it. Awesome. So what you should have found was this. So I used a, oh, my code's not quite right. It should be match sport. We'll change that a bit later, but here's how you would actually code that. So let's jump on in. We'll go new file here and we'll go sport. Equal to basketball. And then we're going to match X against the different cases. So first of all, we're going to check the case as basketball. If that's true, we're then going to print out sport is basketball. Then we're going to check the case is volleyball. Snaky bite, print out sport is volleyball. And then we're going to go check the case is rugby. Snaky bite, print out sport is rugby. And then at the end, we're going to have the default case. I'm going to go print out sport is not known. Save that. And then give it a run. Oh, I didn't do the right code, did I? Just copied it. So that's the variable that we chose. So we need to make sure. And this is better as well because it's see how it's more identifying it. Now we run it. And sport was basketball. Fantastic. So the last thing we need to sort of see, because it's going to be useful for later down the track, is you can use the input command. So what this happens is inside the terminal as you're typing away, you're able to get some input into the game as you're building it. And it's really simple. Basically use the keyword input and store it into an identifier. So to get the input from the user, you literally type in the variable input and then type inside a question that you want the person to ask. And then you can store it as either text, strings, or as strings, integers, or floats. So for example, if I want to store the name of someone, I can store it as a str and then type the input and then please enter your name. So the way that looks, if we go into idle, down here, I'm going to type in a variable. So I'm going to go name equal to str bracket input. Please enter your name. So now, whoop, and then close double bracket, sorry. So see how it pops up, please enter your name. Go Steve. And now if I type in name, it knows that the variable was Steve. So you can then do the same if you want to store an integer, you type in int. So if we want to store the age of someone, you would use the int. And then at the end, height, where we would use float. So the input allows you to store these and typecast them to different variables. Now, if you just type input, you can do that and it will default it down to as a string. But sometimes you want to store it as a number because you might want to do something with the age or the height. Pretty cool. So some things to think about at the end. I know there's probably a lot of information. How would you use conditional statements to create a simple game in Python? So you might have a little dice rolling game, for example. And then how can you think of a real world scenario where the conditional logic was essential? And then how might you understand conditional statement? How might the understanding of conditional statements help you with other programming languages? They're super important, I think. There is a Kahoot down the bottom there, so have a go at the Kahoot and play around with it, because then inside of that, you might learn a little bit more. So that's it for conditional statements from me. Hopefully you've learned something along the way. The more you play around with this, the better you become. Please give us a like and subscribe down the bottom, as it does help with the YouTube algorithm. And yeah, see you next time on Steam with Steve. Adios.